Hello guys! So welcome sa ating next part of our tissue processing, which is decalcification. Yeah. So decalcification is quite special, guys. It's not part of the routine tissue processing. So pansin nyo, di ba, dapat fixation, dehydration. But in between the two is we have decalcification. So ito isa tong bonus round. So for decalcification, so also called as your demineralization, so we remove, guys, your calcium or lime salts from tissues which has calcium or lime salts. So ano ba ang mga specimen na may calcium or lime salts? So we have your bones. Yes, bones are turned into slides. Di ba, kung naalala nyo sa histology, yan, I think I have an image here. We have teeth. We have tuberculous lungs. Yan, lungs that hardened and ayun, nagkaroon ng calcium and lime salts and arteriosclerotic vessels. Yan, mga tumigas na blood vessels. Yan. So guys, this is an example of image of a slide. Yan, focus under the microscope of teeth. Yan. So guys, class, kaya tinatanggal natin itong bone and lime salts, guys, kasi masyado itong matigas for our knife in our microtome. When you will cut a tissue with calcium, yan, it could damage the sharp edge of our knife. So may knife yung microtome natin, yan, yung sharp edge niya. So para maiwasan yun, kailangan tanggalin ang calcium salts. Yan. So para makita ang tissue at makat ng tissue ng teeth ng maayos, so ito, the different stages of your teeth, kailangan tanggalin yung calcium. Yan. Ito, class, naalala nyo, itong bone, this is a bone cell. Hindi bone cell. This is the bone structure. So this is the osteon, the lacuna, the conversion canal. So para makita na ganito kaganda, kalinaw, you need to decalcify your bone. Okay? So guys, ito normally yung blood vessel natin. Yan, di ba? It's a simple squamous epithelial tissue. And it's made up of layers. Pero class, pag yung blood vessel naging arteriosclerotic, yan, masyado nang matigas, guys, we need to decalcify it. So ito ang isang arteriosclerotic vessel. Tingnan nyo naman yung difference nila. So, ayan. So what if the histotechnologists did not calcify the specimen? So it could damage the sharpness of your microtome knife. And class, di ba, our goal is to see, so to ensure that the morphological structure, the architectural pattern of your tissue is clear. Pero class, kung hindi mo tinanggal ng maayos, mayroon tayong bone debris and bone dust. It could obscure the clear morphology of our tissues. Yan, may nakikita ka ba? Ako, ang labo lang, yan, because of bone dust. So, however, guys, that your decalcification has impacts. Yan. Pero meron akong side note dito that when we will decalcify, it is recommended that you will not use alcohol fixatives. Yan. Huwag gagamit daw ng alcohol fixatives kasi decalcification is a long process. So, pag gumamit ka pa ng alcohol fixative, it could slow and prevent the decalcification process. So, alcohol fixatives are not recommended. Yeah. So, however, ayun, pag nag-decalcify ka, what could happen? It could distort tissues, especially if you use a decalcifying agent which is high in concentration. Ito yung magiging side effect ng decalcification. What else, class? Sections float off during staining. So, natatanggal yung section, di ba? Once you cut the tissue ribbons, yan, You float it in the flotation device, tapos ididikit mo sa slide mo. Yan. So, bago magdikit sa slide mo, usually nilagyan natin ng albumin. Yan, para dumikit sa slide. So, in the process of staining na, pag nilagay mo na sa acid solution, natatanggal ulit. Yun yung impact ng decalcification. Natatanggal yung, di ba dapat yung tissue slide nakadikit sa slide. So, yung tissue nakadikit sa slide, yung section. Pero during staining, natatanggal siya. Ayan. What else, guys? Effects on staining. If you over-treated your specimen with acid, or you did not remove the acid carefully, hindi mo siya winash ng maayos, guys, it could inhibit the hematoxylin dye. Due to the process of decalcification, ang side effect niya, hindi okay yung pag-dye ng hematoxylin. And AUC produces a deep red color without differential staining. Masyadong mapula naman. Yan. So these are the effects of decalcification. So kung pwede hindi mag-decalcify, pwede naman. Yan. Pero class, may time na kailangan talaga kasi nga masisira yung microtome knife natin. At ito yung mga consequence nga ng decalcification. Okay, factors, what else? Factors affecting decalcification. Volume. Recommended ratio of fluid to tissue volume is 20:1, just like your fixatives. The minimum volume is 20 times rin. Okay, parang ano na yun, kumbaga, sapat na yun. Pag sumobra class is, tumataas na yung laboratory cost. So yun, 20:1. The same with your fixatives. Concentration. So if you increase the concentration of the acid, you will increase the speed of or the rate of decalcification. However, if you increase the concentration, it could distort the tissue. Ayan. So kung nagmamadali ka, there's no such thing as nagmamadali dapat sa decalcification kasi matagal talaga siya. Usually, your decalcification takes about 24 to 48 hours. Yan, routinely. However, if it's really a dense bone, kung may cortical tissue doon, yan, portion ng bone, it is more than 14 days. Kung gusto mo talagang maayos ang pagde-decalcify sa bone, example, yung mga femur, yan. So, 24 to 48 hours talaga. But, mamaya, pag-usapan pa natin, depending on the size rin. So temperature, heat hastens decalcification. At 37 degrees, however, it impairs nuclear staining of Van Gieson stain for collagen fibers. So at body temperature, kung gumamit ka ng Van Gieson, it could impair the nuclear staining. At kung mas mataas, 55 degrees Celsius, the acid could digest the tissue. Pag naman masyadong mataas. Yan. So siguro talagang ang optimal talaga is 18 to 30 degrees Celsius around room temperature. Yan. You will not go wrong in a room temperature, ambient temperature. So class, for the setup of your decalcification, yan, depending on the size, ito kasi parang siguro small teeth lang or small bone fragments, ganyan. So we suspend it. So we wrap it in a gauze and we suspend it so that all of the areas of the bones of the teeth will be exposed to the decalcifying agent. Kailangan nakasuspend siya so that every surface will have a chance to be exposed sa decalcifying agent natin. So mas okay na nakasuspend kaysa nakalatag sa bottom of the beaker or the container. Okay, so it should be suspended so that all of the areas of the specimen will be exposed. Okay, 24 to 48 hours talaga ang routine. So what are the common? Yeah. So nakasuspend saan? So commonly it's suspended in acids. So nitric acid, hydrochloric acid, formic acid, tetrachloric acid, sulfurous acid, chromic acid, and citric acid. Yan. Meron tayong chelating agents. Yan. So EDTA, guys, is used to chelate calcium, di ba? So, pag sinasabi natin chelate, yan, it envelopes. It envelopes. It hugs. Yan, kinukuha niya yung calcium so that the calcium will be unreactive. Yan, EDTA. However, dito sa EDTA, medyo mabagal daw. Itong ion exchange resin saka electrical ionization in electrophoresis, mabilis daw, mas mabilis. So, ion exchange resin. So, we use a resin. So, the resin has ammonia, ammonium ions. Yan, mamaya tignan natin. Tapos, electrical ionization. So, electrophoresis. So, let's start with acids. So, acids are the most common decalcifying agent. They are most stable, easily available, and cheap. Yan. Doon tayo sa cheap class. Kasi especially if you are trying to decalcify big bones, yan. So, kailangan ang maraming volumes of acid ang kailangan dito. Diba? So let's start. So your nitric acids have many formulation. Marami siyang form. So first is 5 to 10% nitric acid. Most common and the fastest. Yan. However, it inhibits nuclear staining and has yellow discoloration. 5 to 10% nitric acid. Siguro hindi na ito masyadong corrosive sa kamay. Kasi yung concentrated nitric acid talaga sobrang corrosive na yun eh. You need, and it has fumes. You have to use it under a fume hood. Ito, since 5 to 10%, and it's okay. So, formol nitric acid. So, formol, may halong formaldehyde. So, it's more rapid, better in nuclear staining, less tissue destruction. However, use fume hood. Naghalo formaldehyde and nitric acid. Has lesser. So, kumbaga, mas better itong nitric acid. And lessen the yellow discoloration by adding 5% sodium sulfate or 0.1% urea. We also have perennis. It's a decalcifying and a tissue block softener or tissue softener. Mamaya, pag-usapan natin. So, itong perennis, parang what I'm reading, this is an old school. This is a classic decalcifying agent. However, it's slow. It's both a decalcifying and a tissue softener or tissue block softener. I'll talk about perennis later. We also have 10% aqueous nitric acid. So, hinaluan ng distilled water. Yan, 12 to 24 hours is the time that it would decalcify. And it's also rapid with minimal distortion. Fluoroglycine, yan. It's the most rapid. Most common and fastest, 5 to 10. So, fluoroglycine is also fast, okay? And poor nuclear staining. Must be removed. Ito yung key nito ha. Must be removed by 3 changes of 70 to 90% ethanol. So, for fluoroglycine, yung other formulation of nitric acid, wash nyo lang with water. Okay? Pero itong fluoroglycine nitric acid, it's removed through alcohol, 3 changes. So, may 3 lalagyan. Yan. So, on the first R, yan, ilagay mo sa 70% ethanol. Sa second R, ilagay mo sa 70, tapos 80, tapos 90% ethanol. Yan. To wash completely the nitric acid. Because if you do not wash completely the acid, it could affect the staining. The gaseous fluid, it enhances for the silver impregnation of nerve fibers. Yan. Also, other acids, we have formic acid. Yan. Sabi niya, the 5% formic acid is the best general decalcifying agent and fixative. Yan. Best general decalcifying agent. Nagulat ako kasi also it's a good fixative. Yan. Di ba formic acid? Formic acid is from the unbuffered formaldehyde. Okay? Kaya ako nilagyan ng class A, ng parenthesis, sabi ko fixative. Formic acid as fixative. Yan. So, naka-parenthesis. I still have to search the reference on this. Okay? Pero best general decalcifying agents ha. So, baka lang may magtanong, ganyan, sa mga hindi ko alam kasi kung anong basis nito. Kaya, nilagyan ko ng parenthesis. Pero yung some of the reference that I'm reading, yun nga, they are indicating that formic acid is a good fixative. Siguro because it's from formaldehyde. Okay? So, it could last 2 to 7 days ang paggamit ng formic acid. However, it does not affect your nuclear and cytoplasmic stain. It has good staining. Yan. So, siguro ang talagang advantage nitong formic acid, maganda yung nuclear staining unlike in your nitric acid. And hydrochloric, so slower, however, greater tissue distortion. At von Ebner's fluid is classified under hydrochloric acid. So may hydrochloric acid siya for cytologic staining. So meron pa tayong mga chromic, citric acid. Hindi ko nilalagay, guys. So next, chelating agent, your ethylene, diamine, tetraacetic acid. So class, disodium EDTA ang form ng EDTA na ginagamit as a chelating agent. Yan. Yung brand na ginagamit is Versene. V-E-R-S-E-N-E. So class, maganda daw ang EDTA kasi you could also use it for immunohistochemistry and enzyme studies. Siguro yung pinaka-disadvantage ng EDTA that this decalcifying agent is best if you are using these types of studies, immunohistochemistry and enzyme studies. It's both a decalcifying agent and a tissue softener, just like your perennis fluid. However, lagyan nyo rin ng parenthesis tong tissue softener kasi di ko alam kung anong source nito. Pero dalawa rin yung source na nabasa ko na tissue softener din siya. Pero dun sa tissue softener ko, hindi naman kasama tong EDTA. So yan, next is does not interfere with staining and does not distort tissues and enzymes. So yun talaga yung isa sa mga disadvantage na. And so the duration, even though it's small, 1 to 3 weeks, so ang bagal lang talaga nito. And 6 to 8 weeks pag dense cortical bone. Ito yung cortical bone. Yan, yung merong ito outer side. So mas lalo na femur. And the best pH is neutral, 7 to 7.4 pH in using EDTA. So, ion exchange resin, yan. So, we utilize resins. Mamaya pakita ko. Well preserved, its advantage, it preserves the cellular detail faster compared to EDTA and economical. Yan, because you could reuse, sorry, this resin, you could reuse it. Yan, ito yung resin, guys, na pinaka-best na nakita ko sa Google. Yan, below it, yan, are the resin. Yan, itong, ayun o, yung nagsettle sa bottom. So, itong resin parang, sobrang liliit na sago, class. So, pag zinong nyo siya, pag nakita nyo sa Wikipedia, itong ion exchange resin, parang sago yung itsura niya. So, inside it are ammonium sulfonated polystyrene. Yan, ammonium sulfonated polystyrene yung nasa loob. So, what you do is you place your fragments of bones, of teeth there. Yan. So, first is so your calcium is dissolved in your acid or a mineral, example, formic acid, and the removal of calcium and exchange with ammonium ions. Since may ammonium tong resin, magpapalit sila ng calcium. Okay? So, ito, calcified specimen which are 2 to 3 millimeter thick, so may nipis lang, 2 to 3 millimeter thick, could be decalcified within 2 to 3 hours in ion exchange resin. So that's the good news. It doesn't have to be 24 hours to 48 hours. If it's only 2 to 3 millimeter thick, yung maninipis lang talaga, hindi yung mga femur, it could only last for 2 to 3 hours. Yan, that's the good news with ion exchange resin. And you could reuse this one. Yan siya. Okay? So, ayun yung parang mga resins. Ammonium sulfonated polystyrene. Yan. So, it's like this. Yan. Next, guys, is electrophoresis. Yan. So, yun, electrophoresis or Iba yung term ko kanina. Electrical ionization. So, calcium ions are attracted to the negative electrode or cathode. So, kung naalala nyo guys, yung electrophoresis, we apply electrical charge to our tank or media or agar. We apply electrical charge. So, may positive charge, may positive electrode, at saka may negative electrode. So, in the negative electrode, pupunta yung mga positively charged particles. Yung mga sa positive opposite, 'di ba? Positive electrode pupunta yung mga negatively charged particles. Sa negative electrode pupunta yung mga positively charged electrode. So itong negative electrode ang na-attract niya positively charged. So 'di ba ang calcium plus 2. Yan. So it will migrate to your cathode. Yan. So your electrophoresis parang pareho sila ng ion resin. So well-preserved cellular detail, faster. However, one at a time lang. Okay? Kasi nga, ganito lang, simple lang naman electrophoresis. Okay? So, class, you have to prepare your media or your electrolyte solution. Yung environment kung nasaan yung buto or yung specimen. So, based on my research class, kasi ang nasa module, 88%. Ang na-search ko naman, 8% hydrochloric acid plus 10% formic acid. Yan daw yung electrolyte solution where you're going to place your bone. Yan. So this electrolyte solution, if you applied electricity, so the ions will move yan, to the poles kung saan sila attracted. Yan. So this is your electrophoresis tank. So merong electrodes, yan, positive and negative, at may electrolyte solution. So you will add your power supply. Yan, kaya nga electro eh. Yan. And the calcium will migrate to the negatively charged electrode or the cathode area. Yan. So guys, konti na lang. So meron tayong tissue softeners. Yan, nalito ako. Ano yung tissue softeners? Pero in truth, ang ibig sabihin pala, tissue block softeners. Yan, it's for soaking the block phase of trim paraffin blocks. Okay. So guys, these are your paraffin blocks. Okay. So after embedding, ganito yung itsura niya. After placing it in a mold and adding paraffin, ganito yung itsura niya. And apparently, when you are starting to cut, yan, may matigas pa rin. Yan, may matigas pa rin. So you want to soften your tissue block using tissue block softeners or tissue softeners. Okay, so ito yung mga yun, Perennis fluid. So you could submerge your tissue block for 1 to 2 hours. Kung natitigasan, it's gritty. When you slice your specimen, it's gritty, it's hard. You could submerge it 1 to 2 hours in your Perennis fluid. Yan. So kung hindi pa siya black, tissue pa lang siya. So from the start, 12 to 24 hours. We also use Moliflex. Yan, Aqueous phenol, 2% HCl and 1% HCl in 70% alcohol. So Moliflex, however, it causes swelling to your block and make the tissue soapy, masabon, or mabula. Yan, so yan, tissue block softener. They soften the tissue kasi nga, kumbaga, parang ang layo ng napuntahan mo, okay, and apparently, ang tigas pa rin. So, ito yung parang troubleshooting way natin para mapalambot yung tissue block. So, class, washing out yun na. So, post-decalcification. So, you have to completely remove or neutralize the reagents that you use for decalcification, okay? So, for washing out in water, out yan. 30 minutes, kung small lang, i-wash mo ng 30 minutes. Kung large, 1 to 4 hours. Yan. If you use acid, you could neutralize the acid with 2% lithium carbonate or 5 to 10% sodium carbonate. Sodium carbonate. And EDTA, water lang. So class, finally, test for decalcification. We have 3 physical test, radiologic test, and chemical test. So, pag physical test, yan, hawakan mo yung bone. So, touch it, bend it, prick it, probe it, yan, see if kung may calcium pa. So, ako I'm not an expert, so this is very unreliable, okay? We also have radiologic test. So, we use Xray, yan. Positron and Kodak OMAT Xray film, yan. So, this is ideal. However, this is very expensive daw, yan. And it's not applicable when you use mercury chloride fixed tissues. I don't know why. Baka masira yung X-ray kasi mercury chloride is corrosive to metals. And routinely, ang ginagamit natin is chemical test, which is calcium oxalate test. Yan. For routine purposes. Yan. Tignan natin mamaya may... So, dito yung X-ray class. So, this is the head of femur. So, nung 0 hours pa, ito yung head ng femur. Hindi mo pa na-decalcify. But after a few hours yun, opaque na opaque yung itsura pag marami pang calcium. So, pag pakunti ng pakunti yung calcium, yan, palight ng palight yung color. An X-ray following the process of decalcification of femoral head with formic acid or citrate decalcifiers. Yan. So, positron yung ginamit nila. Ganyan. 144 hours. Ilan to? Ayan. So, calcium oxalate test. So, this is for your routine testing. Yan. So, what we do is we get, 5 ml of your decalcifying fluid. So, example, 5% formic acid ang ginamit mo. So, binabad mo doon yung bone, di ba? So, kuha ka ng 5 ml no decalcifying fluid. So, add a piece of litmus paper or use a pH meter with a magnetic stirrer. So, once you get your 5 ml decalcifying fluid, add drop by drop ammonium hydroxide. Ito yun. Yan. Until the pH will reach neutral, pH 7. Tapos, add saturated ammonium oxalate and shake well. So guys, kung marami pang calcium doon sa decalcifying fluid mo, there is immediate precipitation. Wala pang, pagka-shake mo pa lang, meron ng precipitate. But if there are large amounts of calcium, there is immediate precipitation. So there's the need to decalcify further. However, kung konti na lang yung calcium sa decalcifying fluid, wait until 30 minutes. Kasi baka may mag-precipitate pa after 30 minutes. So beyond 30 minutes, kung walang nang nag-precipitate, clear yung decalcifying fluid. Yan, napaka-clear pa yung decalcifying fluid. Wala pala akong laser pointer. Yan, napaka-clear ng decalcifying fluid is negative na sa calcium and okay na, pwede ka na mag-proceed sa washing out tapos dehydration. Pero kung positive, talagang magiging turbid at magkakaroon ng white precipitate. Ayan. So dapat complete decalcification, dapat clear ang fluid after calcium oxalate. So dalawa ang reagent na ginagamit, ammonium hydroxide and saturated ammonium oxalate. Kalimutan. And class, it's best to test for 30 minutes. Yeah. So guys, that's it for today. Thank you for listening. If you have questions, just direct it to our GC. So I'll see you again, guys. Bye-bye.